Hello there, my name is Navin Rukesh, and today I'm going to present my topic on Wheel Mobile Robot. What is a robot? A robot is a pre-programmable, multifunctional manipulator designed to move material, parts, tools, and specialized devices using a pre-programmed movement to perform certain tasks. It is a system that integrates mechanical, electrical, and electronic components together with a software as a control unit. As you can see, there's many different types of wheel mobile robots nowadays in the market. This is one type of the wheel mobile robot. This is a bi-wheel mobile robot. It has two wheels. Each wheel is independent. It allows pivoting in a stationary position by spinning each wheel. Depending on the direction of the wheel spin, it can the robot will be able to turn clockwise and counterclockwise. An omnidirectional robot. It may have more than four wheels. It is able to avoid obstacles and plan paths in its working environment. It uses positioning and navigation to reach an accurate location. It also has good mobility and maneuverability to avoid obstacles and move around. A caterpillar type robot, also known as the snake type robot, is popular for navigation in irregular terrain, which is typically a hazardous environment. This robot is applicable in hazardous environments such as demolishing areas, firefighting, pipeline, bomb diffuser, also space projects. These are other different types of wheel mobile robot. We have the Yamabiko, the Magellan Pro, the Sojourner, the ATRV, the Silhair, and the Koi. In building a mobile robot, there's so many different kind of uh, sensors integrated in a wheel mobile robot. We have a motion sensor to detect motions. We have ultrasonic sensors to detect the objects around. They have infrared sensors to detect heat. Then also visual sensors to detect the visual around. The advantages of a wheel mobile robot is they help people with the tasks that would be difficult or unsafe for the real person to perform. It can be either be a wheel mobile robot can be controlled manually or automatically. Some robots may have memory function. It's also known as the simultaneous localization and mapping (SLAM). It is low cost and simple to construct. In some WMR, depending on the terrain, it's unable to move. A certain some cleaning robots may be inefficient to clean a wide area of space. The recent invention of WMR, as mentioned before, a cooperative cleaning robot using multiple cleaning robot is used for cleaning a certain wide area in nowadays inventions of wheel mobile robots. The purpose of these cleaning robots is to find the alternative for a human labor, since the cost of human labor nowadays are getting very expensive and mobile robots can achieve the same desirable cleanliness. The limitations and resolutions will be further presented, but before that I have a slight presentation on cleaning robots. The simulation was done using NetLogo. As you can see, this is the simulation program. As I set up, this is the dirt. The one in color is the dirt, and the arrows in black is the wheel mobile robot representing. As the wheel mobile robot advances, it cleans up the dirt of the environment. It works cooperatively and it works together around the area of the environment to clean all the dirt. As the wheel mobile robot ends its cleaning, it goes back to home and it dies. Okay, so back to the presentation. The limitations of a wheel mobile robot of this cleaning mobile robot, it has a long time to reach a full coverage for cleaning an area. Due to the robot will have some robot may not have the knowledge that a certain area has been cleaned, and the robot will come and keep cleaning the same area over and over again, or maybe a different robot can come and clean the same area again. This and also cleaning a robot, a real mobile robot is run on battery, and battery is limited battery power. Cleaning strategies are described as random, as semi-random, and not normally result as a normal distribution. Like some in an empty area, each area of the floor will have an equal chance to be cleaned and can be cleaned within a certain amount of time. However, it is not so when the area is not empty, where there are a variety of interior obstacles will increase the odds for the cleaning task. The mobile robot, upon navigating the conveyors of factory, it is able to recognize the obstacles of the factory and avoid it. The same time, assumption is a huge as the robots may frequently be blocked by different shapes of obstacles. Navigation and localization. Mobile robots have operate in large facilities. Many different approaches have been taken for localizing and navigation. In the facility needs to be mapped, route, and planned prior, with which sensors like provides information for the robot for it to recognize the environment and plan a proper trajectory planning. It's also important to know the position and the orientation of the wheel mobile robot, and many methods have been developed for this. This is referred as the SLAM algorithm. Predicting the movements of the people and vehicles in the vicinity of a mobile robot is important for the safety and efficiency. The usually developed plan planning is called dynamic artificial potential fields, in which the planner allows the robot to navigate safely in high dynamic environments even when obstacles move at higher velocities than a mobile robot. The artificial potential algorithm have been used to enable mobile robots to repel static and dynamic obstacles. For example, if if the obstacle is moving or if the obstacle is stationary, the robot will know and be able to avoid. As you can see, this is the trajectory plan where the robot is able to detect the obstacles around it and plan a trajectory for it to move and reach its point from point 0 to point 1. The trajectory tracking and control method, an experiment of the AGV. AGV is an automated guided vehicle. It is prohibited to its field with high efficiency when it comes to handling. The AGV can follow when it reaches the end of its path. It can turn around and continue moving on its own. It requires a wide workspace of operation for the AGV to maneuver around. AGV does not need to turn around to get a different path. Instead, it can use its kinematic model to rotate 180 degrees frontal and backwards. A set path was designed where the AGV moves from point A to point B. The figures will show the path moving of the AGV. As you can see, there are three different figures. The first figure shows that the AGV moving from point A to point B. If the there's no way for the AGV to move, it directs it. This is for the AGV to turn clockwise, counterclockwise, as the head turns 180 degrees and the vehicle is able to move to point A. This is the trajectory plan for the AGV to move, for AGV to turn around, being able to get a proper trajectory. The result from this experiment shows that the great stability and remarkability efficiency of the tracking control. This rule was complex to design but simpler to implement, needlessly resource and calculation improvements. This is a cleaning, as before mentioned, the cleaning robot. This is a cleaning area with with the where cleaning robots are allocated to clean different areas with different amount of cleaning robot depending on the amount of dirt. And some cleaning robots are on standby if there are any problems. The graph or slam graph is a method for sensing. The graph slam is a method that allows to create a blueprint of the entire and working environment, allowing the robot to recognize the environment. This is an example of the graph slam. We have the landmark, odometry, robot pose, loop detection, landmark, and observation. How is it done? The method identifies the surrounding that always present in the factory. This is known as the Gall's method. It's a combination of detecting the environment and detecting environment and planning the geometry. As you can see, this is the Gall's features, the lamp and the surf. Task performance for the cleaning robots. The cleaning robots have been assigned to an area to be cleaned. I apologize, it's the same picture. Illustration of this cleaning, the topology of the cleaning area. This is the topology where the cleaning area is divided. It's much more easier. This is done for the effective modeling of the cleaning area. It's much more easier to divide the cleaning area for the robots. This is a block diagram of the robot performance, where the communicator can communicate with multiple robots to give them a task to do, or the communicator can recognize the conditions of the cleaning robots, knowing the battery level, the condition if there's any breakdowns. This is a basic bill of material for building a wheel mobile robot, where the divided in is just a basic bill of material where it's divided into wheels, sensors, the frame, the motors, the microcontroller. It is estimated to be a total of 151 ringgit. It's basically uh, a cheap model of a wheel mobile robot for any starter person who wants to build one. For conclusion, a wheel mobile robot is manufacturing will be increasingly demanded, and the tasks which they will be expected to accomplish will be much more complex. Due significant increase in prior processing capabilities and hardware robots, mobile cleaning robot will be more common for people and robot to interact in common workspace. A few improvements need to be done to enable the robots to carry the task in an easy and flexible manner, which is to be able to change the task rapidly and deal with the much less constrained work environments that usually is difficult for the robots and the people. Standards will also have to be enhanced and harmonized, especially when the robot incorporate manipulators and detectors and infectors for collecting the garbage. And finally, these are my references from where I got my information, and that will be the end of my presentation. Thank you so much for listening. Bye bye.